And while that is explained now, we continue with this lab here. All right, still not getting through to Kemar, Tiffany.
No, sir.
While that is good. All right, start on. All right, so trying to bring the lab up on the screen. Um, and probably is this one. Here it is. All right. Let's put F11. All right. If you're not getting through to him, I just want to record this then, and so you can send it to him. All right. So, all right. So let's fill in this now. So this is lab 5. All right. Let's put the draw here. It should be on black ink, not white. So this is lab 5, guys, and then today's date is the 14th of the 4th, 2021. All right. As you can see now, the aim is to determine the focal length of a convex lens. All right. So let me just adjust this. And there you go. All right. Focal length here, guys, of the lens. All right. Have you done this at CXC before? Have you seen what a lens is? Yes, Stephanie? Tiffany, it's on like internet connection poor.
Sir, yeah, hear me?
Yeah, go ahead.
Yes, sir.
Okay, you did. Okay, fine. So you did the focal length of a lens. All right. Um. All right. So you should be familiar with it. Caris, I don't think I did it with you guys. I think our time was cut short and we didn't do this lab. But certainly it was something that should have been done. But nonetheless, we're just going to go through it now anyway. All right. As you can see now, this part is in module 2. So 3.5 to 3.9. So you can call it, say, from you do this lab and do it properly, would have covered this part of module 2. So you wouldn't have this part to worry about. So, and that's what the next labs are going to be about. Just covering some topics where we don't do yet. And then we explain it afterwards. All right. So guys, this is the setup here for the lab. And then I'm gonna show you what it looks like now virtually. Let me just show you what the screen looks like. Is it everybody seeing the screen here?
Yes, sir.
All right.
Yes, sir.
All right, good. So what we're going to do here is just collect some data here. The idea is that and we have the instructions to follow. Really, it's just to adjust this lens until the image is formed. Let's go down closer. Everybody seeing the image that is formed on the right hand side?
Yes, sir.
All right. So the lens is placed between the object and the screen. All right. When we move this lens, it changes the image that is formed. So the object is always the same. However, the distance between the object and the screen can change, and then that will affect the image that's formed. All right. So object on the left, image on the right. Everybody understand that?
Yes, sir.
All right. So doing there. All right. So if we should follow the instructions here, let's see. And they say we should choose a lens. So we have 3 different lenses to choose from, but for this lab, we're just going to do one lens. Doing in the interest of time. All right. Now let's scroll through and see here. All right. The idea here is that each distance we move this lens from the object, we're supposed to record what happened. Also, we should be able to locate the image here, and let's see if we can turn this around so you can see what's happening here. And then for some angles, Yeah, you notice that again, it's just that distance there that affects the image as far. All right, so we're seeing this happening. All right, now the key for this lab now. This lab is going to be have ORR and AI. This could be M&M too as well. I might just change this into a MM lab though, because if we're not meeting face to face to do any, then we don't have any choice. We have to just use the lab here. All right, so but the skill is on the lab sheet. So which means that if it's ORR and AI, it means that you'll be getting marks um for the data, for the information you put in the table. All right, this lab also has a table as well as P and Q. All right, this is showing the object distance and image distance. So P is the object and Q is the image. All right. Also, this is a function to record the data. So, all right. So we just need to adjust this and set it up. All right. So that's basically what we're doing today. Just trying to fill up this table here. And you will put those results in your lab sheet. And it's going to involve you plotting a graph as well. And so I should probably just give a new slide and show you what that graph look like. All right. Any questions so far, guys?
No, sir.
Okay.
No, sir.
All right, very good. All right, let's continue here. So let me just locate a graph paper so that and you're going to notice keep really big on graphs here. The moderators come and don't say, yeah, you know, a lot of graphs, then they probably wondering if it's really capable doing so. We have to make sure we have that covered. All right. Let's see. All right, so I have a nice graph leaf on the other screen. So let me just save that. And let me continue. Yeah, let me replace that file certainly.
Sir, you're low.
Well, low because I'm not saying anything. Let's see. Right, anyway, am I still low? All right. But like you totally gone, so you know. All right, let's close this one. Recording data show table. Close that one. All right, guys, here we are. Following the steps here. All right. Read what you see here, guys.
If you can't see an image for the arrow, then the lens is at a distance p smaller than or equal to the focal length of the lens move.
All right, stick up in there. Full stop there. All right, that part there, as they say, yes, if you can't see the image for the arrow, then the lens is at a distance p. All right, so p is used for the distance here. That is smaller than or equal to the focal length of the lens, guys. All right. So there are some rules for this for how this lens work that will they certainly could ask at an exam. All right, so I'm gonna add that information into the lab as well. So it's good that we read that part because it's very important, guys. All right, so convex lens or we call it lens image formation. All right, there are actually 5 rules for the convex lens, and those have to do with the distance that produce images. All right, not see it here, but all right, there you go. All right, so this is saying that, guys, that if we cannot see an image, right? If you can't see an image for the arrow, right? If you can't see an image, let me just move this around and show you something. All right, so we know that the arrow is always here at the moment it's 17 centimeters away. No, they're going to come a point where you can't see it. You see that?
Yes, sir.
Yeah, so at 9.3, you're not seeing anything. And I move it up to 9.6, still not seeing anything. And look at that, 10.7, you're starting to see something. So this is telling us quite a bit about this lens. In fact, this is telling us that we have reached it's actually called the focal length of the lens. The objective is to find that focal length. And we could simply do it like this, and then it would be, notice that there's no image there. So that's the focal length of the lens, guys. All right. And why there's no image is that it's something like this. When you focus on one thing, it's like nothing else matter. So therefore, there could be the best of things happening around you, but because you focus on that one thing, right? It could be food. It could be some guy that you like, and then nobody else matter. All right. So it's the same thing here with this lens. All right. So once you lock the focus, no image will be formed. All right. So let me just put that on the lab sheet so you can get all that information, guys. All right. So then the aim is that we're going to try this for several distances. I want to see what happens here. We have to do a distance that is all right, let's see if we find this image. If we start from a small distance here, that would be good. All right, so let's start here. When we can probably start from like 7 then. All right, and then let's go around to see if there's no image form. So 7 centimeters, no image form. So what we're gonna do here is do a recording of that data, guys, and it just hit record data. It's not showing up. I'm not seeing an image, but we could write it on our lab sheet, guys. So I'm going to put it on the lab sheet so that when we go back to it, you can see it. All right. And I probably should change this one as well. All right. Distance of object from the screen at the moment is 7 centimeters. Remember, the object is on the left, and it's this arrow here. All right. And of course, the distance of the image, there's no image. So we're going to put like a blank space here. In fact, distance of image, no image form, that's 0. All right. And then no description of the image, you're going to write no image. So that would be on the lab sheet. So let me quickly move across to it and show you what that looks like on the table so you can fill it out. All right. Everybody seen that?
Yes, sir.
All right, so good. We're filling out the table. So all right, let's switch back now to the lab itself. All right. So so when you continue like that. All right, and let's move this image. We can probably go up by well, we start 7. All right. Maybe we can this was somewhere there to want to accurately find that point there. All right, so at 9.6, we're also not seeing an image. And then even at 9.3, there's no image. And so there's some uncertainty here because at 9.3, there's no image. 9.6, there's no image. Let me put down those values here. 9.3, 9.6. Distance of image from is 0 there. And we have no image. All right, guys. So this is telling us something. This is telling us that the focal length of this lens is somewhere in that range. If we should increase this now to 10, we're seeing that there's an image. But then the rule says for this lens that we should adjust the screen until a sharp image is formed. That is a precaution, guys. We're going to write that in the precaution that the screen must be adjusted. All right. So this is this screen now. So we must move it until the image on this black screen here is as sharp as possible. And you see that this one is blurry, but then we come up closer. It gets we still can get a sharp image here. This is something here, but certainly this is blurry. Everybody seeing that? We get a blurry image here.
Yes, sir.
Yes, sir.
All right, and then we're coming closer. It gets a little bit sharper, but still not getting as sharp as it can be. So the rule says that we should adjust until the sharpest image is formed. So right after the precaution, the screen was adjusted until the sharpest possible image, and it was formed. All right, so there you go. Again, sharpness of the image is very subjective. The sharpest image, and then that's the distance that we're going to record in the table. We're the one that give us the sharpest image. Even this looks a bit sharper though. I don't know if you can see what I'm seeing. You know, looking at it through the lens, it looks like the closer we get is the sharper it look. What is seeing that?
Yes, sir.
Yes, sir.
All right. So, what's happening here is, all right, the object distance is 10 centimeters and the image distance is looking to be 17.4. Now, we're going to have to subtract the 10 from the 17.4. So, that will give us the distance of the image from the lens. All right. So, when you subtract 10 from 17.4, what number we get?
2.4.
Yeah. Okay. So, you're going to get what? What's the answer there?
7.4.
Yeah, 7.4 definitely is the correct answer. And we are seeing an image. All right. Now, guys, this is where you get the marks for ORR for the observation and reporting and recording. All right. What all right. First of all, let's compare the size and the and of course the what we call the orientation, really how the image look. Compare both images and what can you say is different between them, the object and the image. All right, let's describe the object first. All right, so when the arrow is pointing up, all right, we use a term to describe that type of object, and we say that the object is upright. All right, so the words that we use to describe images are upright. All right, you're also gonna say if it's real as well. Well, the of course the image rather, and image what you call now? These are image description. Yeah. Image description, guys. You can say, so you must say it's upright or inverted. All right. You can say if it's real or virtual. I'm going to talk about what that is soon. And then of course you're gonna say if it's magnified, which means bigger or smaller than the object. And then of course magnified, or if it is diminished. The opposite of magnified is diminished. All right, so magnified or diminished. All right, so when them ask you in exam to describe the type of image as formed, you're gonna use those words. All right, when you put those words on the lab sheet so you can see them, put them beside each other. These are contrasting words, similar to when you were learning about antonyms in English. So I put them on the lab sheet, help you to do your observation. All right, so now guys, let's get the results in the table. Distance from the screen at the moment of the object from the screen is 10, and the distance of the image formed is actually 7.4. All right. So for some reason, a student is in the waiting room, but then I guess they made a mistake there. All right. So we're good with this now. All right. So let's talk about this image now. How could we describe the image? let's look at the first one. Is it upright or inverted? So here's the object and here's the image. Is the image upright or inverted?
Inverted.
Very good. So we're gonna put inverted as the description. All right. Is it magnified or diminished?
Diminished.
Diminished. All right. So diminished here actually means smaller. So yeah. All right. And is it real or virtual? No, that is something we need to discuss here. All right. So long story short, guys, that a real image is one that's formed on the opposite side of the lens. So and once you're seeing and once you're seeing the object on one side and the image on the other side, then it means that the uh object, that means that the image is real. All right. It's really forming from the object. So that's why it's called real image. All right. Now, a virtual image now is one that is formed on the same side as the object. So it means that if you were to find out a virtual image now, it will appear on the same side as where the object is. All right. Now, this happens with a magnifying glass when you're trying to look at an object and the object appears bigger. But is the object really as big as you're seeing? All right. So that's the question. And the answer for that should be no, because if you are looking at let's say a small ant, for example, if the ant is already small, you put a lens in front of it. The lens that you what you call a lens is a magnifying glass, but what they didn't teach you is that it's a lens that when you carry the lens close to an object, it magnifies the image because it's producing a virtual image. So the ant is not really as big as you're seeing in the lens. It just appears bigger, but it's not really bigger. So then that's a virtual image. All right. So take from that what you understand, and let's move on. Inverted, diminished, and this is actually a real because it's on the opposite side of the lens. Any questions here, guys?
No, sir.
All right. So let's pass that fast. All right. So now we have seven. Well, we actually have four results already. So let's continue this then. We want to see how the other images. So usually now how we use this lens. If the focal length is let's say if it's 10, we try and double it. So I want to make it double that of 10 and see how it behaves. So this is double of 10 is actually 20. I want to see how that lens behave right there. All right. And remember, we are just, you see, that's a sharp image. Everybody see that the how sharp this image is? And hope you've seen it. See the sharpness of the image is all right. So it basically means that you set it in such a way that most of the light that leave the object reach on the screen. And if you can get 99% of the light leaving the object to reach the screen, then the image will be sharp. All right. So that's how you get a sharp image. So this works on things like phones and so on. So every phone is different when you're taking pictures. So bear that in mind. The same principle. All right. Any questions here, guys? All right.
No, sir.
All right. No, yeah, there you go. We're getting a sharp image right there. All right. So when we record this one, so the lens is what 20 centimeters away. And from the object, but the image or the sharpest image that we get is actually 38.5. Okay, so it's 38.5. All right, so for one of them, when I take away 20 from 38.5, and what number you get?
18.5.
Yeah, definitely 18.5 there. and we're going to describe this image. All right. So what can we say about this image? Is the image what? Upright, inverted?
Sir, inverted.
And what else? What else can we say about it? Right. All right. So you guys struggling a bit there. Not expecting that, but that's how life is. All right.
Sir,
Yes.
sir, what was the question?
All right. The question was to describe the image.
Sir, it is sharp and it is inverted.
All right. We said inverted. But what about the words I gave you before? I gave you
Oh,
3 words to describe the image, and you're going to use them back to describe this. So the inverted part is correct. What else can we say about it?
sir, it diminished.
Diminished. All right. Let's write that. Diminished. What else? All right. All right. Let's move on then.
Sir,
Continue.
diminution what, sir?
All right. You'll see it on the lab sheet. So let's continue. All right. All right. We'll see get a sharp image here. All right. So now what we're gonna do, guys, is let's increase this because I think I've seen a pattern with this lens here. Let's put it at about 23 and see. Let's see if we can get a sharp image. We're aiming for an image that is at the same size as the object. So we want to see what would cause that to happen. We want a case where the object and the image is at the same size. I think we passed something there. Oh, this one is just magnified a bit. All right, let's see if we double it, we get 18. All right, we got 19. Let me see something here. Sharp image. 19 and 19, 38. So no, I think it's gonna be a little bit further. Let's try 21.9. No, we're not getting it. We want it to be at about the same size. So I think let's try 24. No sharp image. I want the image again to just look just about the same size as the object. Not getting that to happen. We're getting a lot of diminished images. I want something that's the same size. Look at that. That one was sharp. That one was sharp. That one was sharp. All right. So let's see. Let's compare the size here. So this looks a little bit bigger, all right? And this will get blurry again. So the 9 and 9 is we find out 9.3 and 9.3 is 18.6. I'm trying to see if we get look at this. Let me see some. This looks almost the same size. There's really no way of measuring. So the sources of error would be that we have to put that to the source of error now, guys. We have to we're seeing that the limitations in inability, and this we can really minimize inability to determine the size or height of the image. All right. This was purely subjective. All right. So I'm gonna write all of what I'm saying now. I'm writing it on the lab sheet so you can get it to right when you're doing it. All right. Anyway, at 17, So I guess we are going to have to go adjust some of the data here. I'm going to push down the 20 and the information that we have for the 20. And then and probably just even do another table as well. All right, so this is 20 and all right, but right now we have 17 centimeters away from the screen, and we have here an image at 41.1. Let's see if this is the accurate though. Again, we're moving it until the sharpest image is formed. This is actually 40, still sharp, 40.4. All right, and it just gets sharp right about 40.4, even 40. It gives you a sharp image. So we're onto something here. Is this the same size as the object? It would appear so. I mean, if you look at it, but let's write that down. So when you take away 17 from 40, what's the distance of the image from the lens? 17 from 40. What's that number? All right,
23.
23. All right. All right. Again, let's describe this as the same size. Same size. And of course it's real. All right. All right. So we have, so actually went down a bit. All right. So if we have 17 and we get the same size, we're going to try what happens if we double that 17 and we get 38, 17 and 34 actually. So let's put this at 34. So it'll be 34. Exactly. Is it? No, can't get it exactly 30. Well, 34.1 is not bad. All right. So let's see what happens there. Can we get a sharp image at double the 17 that we got a while ago? Again, let's zoom out. All right. Yeah, we're gonna have to zoom out a bit so we can get more space. No sharp image. A sharp image here. Nothing sharp, fam, guys. And get blurry. Not sharpening. So you're getting more magnified as we move it away. And we're carrying it closer. And let's see what happens here. All right, look at, well, no, not sharp, guys, not sharp. Well, probably zoom in. Still not sharp. Oh yeah, they're sharp. Oh, look at that, guys. But you see that? The sharp image, but it's small. All right, blurry, sharp. All right, and we have some results here. 34 will give us a sharp image, but what can we say about this one? All right. So 47, sorry, 34 from 47. 34 from 47.
12.9.
12.9. Yeah, 12.9, definitely there. All right, so 34 and we're at 12.9. All right, object, as you can see, much smaller. So the word I use there is diminished. And then of course it's real. All right. It's interesting though when we're not getting a magnified image though. Oh, whoa. Get a magnified image here at 14. So if we go put this thing there, this looks nice and
Yeah, talk.
all right.
Okay,
All right.
internet working good.
You all right, if you don't catch anything, it will be on the video. So somebody drop off. Who drop off? Oh. All right, Carrie is still there, right?
Yes, sir.
All right. All right, we have to go record this, We have nothing for 14.4. And then we have to go arrange this table now afterwards. Um, and this look bigger. 14.4, we get how much bigger? All right, 14.4. And you take away that from 46.7. Mm. Right. So if you take away 14.4 from 46.7, then that's gonna give us what number? All right. That certainly will be what 22.3. It should be
32.3.
mm, 32.3. All right, so let's go there. 32.3. 32.3. And the object now is inverted, just the same. All right. And or rather the image is inverted. All right, image is inverted, but it's instead of saying diminished or same size, we're gonna say what? It's gonna be magnified,
Yeah.
and of course real. So all right, I think we have enough. I think we have enough data for this. We cover all the grounds here, and so this is basically this is basically true. Um, all right, so that's it. Any questions here? Good. Can go over.
Yes, sir. You can move on.
Let's just change the screen now and go back to the lab sheet here. All right, guys. So this is what the table looks like now. It's right now. Uh, look a bit messy though, but I'm going to fix it up. All right, you can fix it up. I'm going to see something. I get a blank Word document, and I think the tables in Word are much better. So let me. Oh, I'm gonna try it. I'm going to set it up here. All right. So I'm going to simplify this table. Or let's say draw a table. No. All right. So for this table now, and if I were to show you the 20, this would be what the 20. If you look at the 2019 exam Cape paper, it's the same lab came on it. That was the first question. All right. Okay. All right. Let's see how much columns we have here. So 5, 7, 8. I use 8. All right. I mean 8 rows rather, and about 5 columns. Yeah, about 5 columns here. All right. Simplify that for you guys. All right. Now, all right. So now, guys, this data now we're going to fix it up. Put them in numerical order. So it will be 7, 9.3, 9.6, 10. Then you will have 14.4. Then you're going to have what? 17. Then you're going to have 20, and then you're going to have 34. That's the order in which you're going to have it when on your table. All right. And all right, there you go. All right. Let's see, you can adjust the size of this now. All right. So I'm going to fix up this table, and then you're going to see me copy it over here. So the distance, all right, distance of object from screen in centimeters.
Sure, may I go log out and coming back because this a show blurry.
Oh, all right. Yeah. All right. Still there, Caris?
Yes, sir.
This one's so stressed out.
Sir,
Mm?
sir, I'm stressed at the moment.
You stressed at the moment?
No, sir, not yet.
Okay. All right. So let's fix up this as the image from the screen. All right. Distance of image from the screen. You have 1 over u and then 1 over v. All right. So that's another thing I should point out to you guys. The standard symbols here. The standard symbols. In well, for, according to CXC, you want to see this formula here, the focal length formula, guys. 1 over f is equal to 1 over v plus 1 over u. U is the symbol for the object, and so that's actually u. So distance, I'm going to put u. Although in this lab, those persons who did the virtual lab or designed the virtual lab, they actually use P and Q, but then at CXE, which is in the Caribbean, them use U and V. All right, so let's put V so that you know that V is the image distance in the formula that they expect you to know. So 1 over F means 1 over focal length is equal to 1 over image distance plus 1 over object distance. And then you should get these being equal to the focal length when you add them up. All right. So from this lab, you're going to actually plot a graph and show that this formula is true. All right. So this now would be in centimeters. The focal length would be in centimeters. All right. So let me just get this table organized for you guys, and we'll take it from there. All right. So there we go. Hopefully, yeah, it's gonna be there. All right, and then of course looking at the description now, and this is where the marks will be coming from, the accurate description of image. And then at least this lab is loaded with things where you get marked for anyway. All right, so highlighting this now, put it in bold and change the font here to something that you can read. All right, now you should be seeing this. Let me see if I can copy this table. Nope. All right, press cut into that copy. Copy here. Let me see if I can get a blank sheet now. Let's move this away. Then, yeah, it's about that. All right, right here. Yeah, so if everybody's seeing this, so let me just refill this table now, guys, with the accurate thing. As a matter of fact, let me go here, and I forgot to select everything here. So, all right, no problem there, no problem. I'll copy it and put it up here, so I write it off. Here we go. Good. So we can easily crop here. Let me see so we can format the picture. Yeah, crop out that part here. So all right, good. So everybody should be seeing this now. Let's copy what we have here onto the table. So we have here distance object from screen. We have 7. We have 9.3. Again, the numeric order is what we're going after here. 9.6 there. and we have that should be 10. Then we're gonna have 14.4, and then we have 17, and then 20, and then 34. All right, so that's what you're going to look in your own. All right, remember, and the second column now, guys, it's gonna be 1/u. So you're going to put this in your calculator and get the answer here. All right, this is where you get marks for the analysis, your calculations rather. All right, so you can go ahead and do that, and then I will give you write down the distance of the image according to this here. All right, so besides 7, we had 0. No image formed, also at 9.3 and 9.6. Image was actually formed at, so it's actually going to be at 10, which will give us 7.4. All right, and then let's push this up here some more. All right. Oh, this is thing out of sync now, man. All right, no problem there. All right. So at 10, we got 7.4. At 14.4, we got 32.3. And then at 17, we got 23. At 20, we got 18.5. And at 34, we got 12.9. That's the table, guys. That's the table. And then the description now, we got description of image. There's none for that one, none for this one as well. And then of course, we can just use symbols inverted, diminished, and real, IDR, for number 10. All right. So just remember what I stand for, and D and R. All right. 14.4 now. Was at 32.3. It was magnified. So it will be inverted, magnified, and real. All right. And for 17 now, it was at 23. We got the same size. So yeah, which is inverted, same size, or the same as object, and this was also real. 20 is the same. Well, at 20 now it was diminished, so definitely it was IDR. And then 34 now was certainly diminished as well. All right, let me just confirm 20 being diminished. Okay, and it's IDR. All right, so that's it. That's the table, guys. Again, you have this part to do 1/u and then 1/v. Put that here. And then you plot your graph. The graph is gonna be 1/u. It's gonna be 1/u against 1/v. In fact, let me show you what that graph should look like. All right. All right. So 1/u versus 1/v graph. All right. All right. No, this is interesting, guys. Let me show you what it's supposed to get. All right, so how the graph supposed to stay, guys? New side here. This is how the graph supposed to look. Everybody see that? So it's gonna be, so you basically going to plot 1/v against 1/u. The graph supposed to look like this. It's supposed to be a straight line and downward slope there. All right. So yeah, that's what the graph going to look like. But the graph will only look like that if you work out these values and put them in there, which this is your results. Let me see what's happening up here. All right, so again, we show you on the other page. So this is actually the results. All right, so the result must have a title. So table showing UV data for convex lens. All right, so just in mind. Any questions here, guys? You don't understand what's happening so far?
Yes, sir.
Sir, you saying tables of the workout?
You're going to put 1 over U for each of these and put the result here.
So that be
Right?
1/7?
Yes, 1/7.
Mm.
All right. And you're going to use like 1 decimal place. If when you use 1 decimal place, you get the 2 same number. You use 2 decimal place. So 1/7. And you give me the answer to 2. All right, yeah, try 2 decimal place. That probably might be better. 2 decimal places. So 1/7 to 2 decimal places. That is how much? So 1 divided by 7. The answer to 2 decimal places is what? Okay, bit slow there. Definitely 0.14 according to this calculation. All right, and you're going to do the same thing. You know, let me even change the color here. Well, let me see, it makes sense really. Let's change it to red. Yeah, all right. So you actually can see the difference there. Let's just put this in red. All right, so all right, and so you're going to get 0. Well, so you get a number like this, 0.107, and you just call it 0.11. All right, that's what you're going to do. So you guys going to do the rest. All right. But then these don't matter because, well, we don't have any well, this is actually on the intercept anyway, so that's cool. Yeah, these don't have any values. You know, 1/0 is definitely 0. So, and we're just getting the practice here, really. 1/9.6 should give you the same thing though. You know, let me just check. And I'll confirm really on this calculator. So 1 divided by 9.6. And that's, yeah, certainly 0.10. Yeah, definitely 0.10 here. Okay, so pretty close there. 1/10 though would be 0.1. So again, we're getting these values are the same when you round it off. So you'll be tempted to probably use 3 decimal places. Well, I suppose if we use 3 decimal places, let's go back to the result from the calculator. So we have 0.104. So the third decimal place would have been 4 for that would be 9.6. All right. However, for 10, it's actually 0. So so there is a difference, but then to 2 decimal places, again, this is another source of error. See, this is a source of error. So source of error here, what we have here, the precision, all right, or the All right, rounding off values of 1 over u and 1 over v to 2 dp. Actually, you could say increase uncertainty in the results. All right, so running our values of 1 over v and 1 over u to 2 dp increase uncertainty, because if we left it, as you can see there, uncertainty is a possibility of an error in the results, and once we make note of it, then this can stay. All right, so difference there. All right, 1 over 7.4 should give us something close to 0.14. And if you go on your calculator and put that in, let's press this, it's going to be 1 divided by 7.4, and that's for the 1 over v side, and you're going to get, all right, so this is going to be, and here's another thing now, so it's going to approximately be 0.14 rather, so 0.14 would be here, no problems there, so we'll see him. And of course 1 over 14.4, you guys can do that. All right, just wanted to see what the results look like, and then all right, so this is it. Any questions here, guys?
Sorry, I can repeat it. You get the 0.14 over that side here.
Didn't you see what I was doing on the calculator? Can you see it here? 0.135, and it round off to 0.14.
Okay.
Yeah. All right. Anyway, so that's 1 over v and 1 over u. All right, so guys, this is it. I think you guys should be able to finish this on your own. And again, you a lot of research here. All right, this part now, I think here on your lab sheet, this part is clearer, so I can remove this. I don't know when this convert to PowerPoint, it start look weird. So these things come into play here. All right, so yeah, guys, so all right, so finish the table and plot the graph, and that's it. I think that's the end of class. Seeing some grade 10 students here.
Sir, you send discussion question for yourself, labs them, sir.
They are in there. They are in there.
Oh.
Every lab that I send, you have discussion questions. So and here they are. See it here, all of them. So if there's one thing my labs always have is discussion questions. So they are there.
Sir, one problem with one calculation, sir.
With one? A problem with a calculation?
Sir, me da have one problem with one lab one. Not with the calculation. Sir, the type of thing I want to stop. Let me see.
All right.